Okay, so the first thing I want to talk about, okay, in 6.1 is dilations. Okay, so we did a little bit of this in the Desmos activity. Alright, a dilation, to dilate something, like I don't know if you know about your eyes being dilated when you go to the eye doctor. I don't know if you guys go to the optometrist, but when they dilate your eyes, I don't even know what it is, but your pupils either get smaller or bigger. They change size, like they grow or they shrink, and that's what a dilation is. Okay, it's like when you're making something bigger or smaller. All right, so this is just an example, and you'll see what I mean when you get to the practice quiz. Okay, but let's say that I had two triangles. Okay, I'll give you we'll say that's the small one. We'll say over here is a bigger one. Okay, let's say this side's 2. Say this side. I'm just making numbers up, okay? That one's 2. Let's say this one's 3. Okay, then we'll make this one 4, and we'll make that one 6. Okay, so if you assume that these are one of these is a dilation of the other, okay? So if you remember these terms from last year, we talked about the first one was the pre-image. You guys, that might sound familiar. The second one was the image, like the before and after. All right, so what the kind of question I'm going to ask you now, notice I didn't give you the third side. I could have, if I made it up, say this was 5. Okay, we'll get to this later in a second. Okay, but there's kind of two parts to this. Okay, the first thing I'm going to ask you is how much is it dilated? Okay, and the word for that, the mathlish word that we use for that is scale factor. Okay, so if you think about scaling a graph or scaling something like going by 2s, going by 3s. Alright, a scale factor is basically how much we multiplied or divided by to get from the before to the after. So it's it's kind of how much it was dilated is the scale factor. Okay, so for this one right here, there's two things we can do. We can look at this side and this side, right? We want to match up the sides. Okay, so the first one was 2, the second one was 4. All right, well the bottom was 3, this one was 6. So what is the scale factor, or how much was it dilated by? It was multiplied by 2. Okay, that would be the actual scale factor for this example, would be multiplied by 2. And all that means is that to get from the pre-image to the image, the before to the after, you would just have to take all the sides on the pre-image, multiply them by 2, and that would give you the new side on the image. So going back to our question mark now, right? We know the scale factor is multiplying by 2, so hopefully you already figured this out. But if I asked you what this hypotenuse was of the image, the after, if we were looking for this, all we would have to do is take this hypotenuse, multiply it by 2, and that would be our answer. All right, so hopefully you guys were seeing that already, but that's the second part of how we can use the scale factor. Not only obviously we need to be able to understand oh, they're multiplying by 2. Okay, but knowing that, we need to be able to use that information to find a missing side if we needed to. All right, that's all we've been talking about lately is finding sides and angles, and we're going to continue that this chapter. All right, this is just another way that we can find sides. If you know one triangle is a dilation of the other, then you just look at what all the sides are multiplied by and do the same thing. All right, you're going to see a question like that on your practice quiz. All right, for the rest of your practice quiz now, that was kind of the long part. All I really want to talk about, okay, we talked about finding missing sides and angles. Okay, there's going to be some other stuff we do, okay, in this chapter that it's going to be other ways of finding sides and angles. Okay, so so far we did all those theorems, right? Triangles equal 180, straight lines equal 180, corresponding angles are congruent, all those theorems, right, to help us find sides and angles. Pythagorean theorem. Now we're just going to learn other ways. Okay, so if the pictures look a little different, we still need to be able to find missing sides and angles, basically. So we're gonna go a little more in depth into what we've already been doing, and we're gonna start talking about trigonometry. I always spell it wrong. Trigonometry. Doesn't really matter how you spell it, okay? As long as you know what it means, how to say it, what it sounds like. All right, so I don't even know if that's spelled right, to be honest with you. I always call it trig. Let me look it up, though, just so I can give you guys the right spelling. Looks like that is right. For some reason, it just looks really wrong to me. That's why I hate words, man. Anyways. So, trigonometry, okay, is basically finding sides and angles, all right, using, mostly triangles, all right? So, that's why we're going to be talking a lot about triangles. So, today, okay, all I really want to get at is that for any given triangle, okay, we're starting with right triangle trigonometry, just so you guys know. So all the triangles we're drawing in this chapter, most of them are going to be right triangles. All right, so what I want to get at, all I really want you guys to understand today is how we're going to talk about the different sides of this triangle. Okay, so first off, I want to start with the one we already know. That's the longest one, and we call that the hypotenuse. Okay, there's two ways to remember the hypotenuse. You can either think of it as the longest side of the triangle. Okay, but like in a picture like this, right? If you don't have numbers written, you don't know how long the sides are. We can also think about it as the side that's opposite or across from the square, from the right angle, from the 90-degree angle. So when I say opposite, if you look at that arrow, I mean like across, like draw an arrow away from the square, it would hit that side. Okay, that's the hypotenuse. All right, so that's nothing really new so far. But the two other things we're going to start talking about now are opposite and adjacent sides. Okay? But the thing here is that it's going to depend on where you're standing. Okay, so we're going to imagine here, okay, that we're standing on B. All right, now, I think this is going to kind of be common sense, right? The opposite side of B now would be this one. Same idea, right? We just draw an arrow out of the angle, it would hit that side. So that's the opposite side. I feel like that's kind of obvious. All right, the only one that's kind of going to be new that you haven't maybe heard before is adjacent. All right, so again, this chapter I'm going to be showing you new ways of finding missing sides and angles, okay? Like in addition to what we've already learned, so that you have more tools in your toolbox. All right, but before we can do any of that, it all really depends on you understanding how we label these sides. Okay, there's always going to be a hypotenuse, and then depending on where you stand, okay, there's going to be an opposite and an adjacent. Okay, the one other thing I want to just make sure that you guys understand is, if we were standing on a different one, if we were standing from A instead of B, okay, so let me go back. I'm going to erase all this red here because we're not there anymore. All right, if we were standing on A, so let's move over here. And I'm assuming you're watching this video, so you should see both. You should see my erasing. And if you need to draw a new triangle, you can. All right, but if we were standing on A, okay, the hypotenuse never changes, but now opposite of A is not right there anymore. Opposite of A is down here. And then the adjacent to A is going to be right here. Okay, what adjacent means, the word itself, adjacent means next to. Okay, so like if you think about like your next door neighbor, you live right next to them, right? Your houses, you could also say that they're adjacent to each other. And that would like make you sound really smart, but it's really the same thing as just saying your houses are right next to each other. Okay, adjacent. So the reason when we say adjacent, right, there's technically two sides that are next to A. Like if you think about it as next to, we could think about it like this side, right? Or there's this side. But remember, that side the second side I just drew, this one here, that's the hypotenuse. So if it's the hypotenuse and we know it's the hypotenuse, then it can't be the adjacent. So that's why it kind of just leaves this one over here. This one has to be the adjacent by process of elimination. All right, because we know we have the opposite is obviously opposite of the A. Okay, the hypotenuse is across from the B, so that only leaves one side left. This has to be the adjacent side. Okay, so long story short, the hypotenuse is always the hypotenuse. The opposite and adjacent, though, will switch depending on if you're standing from A or if you're looking from B. Okay, and the problem will have to tell you. All right, so I just want to give you an example here real quick of like what this might look like. I give you a triangle here, and I give you A, B, and C. What your question would look like, and let me just give you random numbers here. Okay, because in your problems, they're going to be numbers. All right, so what I might ask you is, what is adjacent to B? Okay, what is the side adjacent to B? So first we have to understand, okay, that we're standing from B. That's our reference point. Okay? And so remember, we know that opposite of B, right, would be this one. If we draw a line opposite, it would be that, but they're not asking for opposite. Okay, so it's not the 5, right? We know that 13 up here, right, this is the hypotenuse. It's across from the C. It's across from the 90-degree angle. So it's not that one. It would have to be this one. Okay, so if they're asking you what is adjacent to B, it would be 12. Okay, and the name of it, think about like that distance is technically the distance from B to C, which is really just a line segment. Okay, so if you're, this is all you need to be able to do on your practice quiz tonight. You need to be able to tell what's opposite, what's adjacent, what the hypotenuse is. Okay, so email me if you guys have any questions. I apologize about the internet thing. Okay, this 6.1 practice quiz is due on Thursday. Okay, so email me with any questions until then. Okay, have a great day.